Alright, now we have a little math. A given force exerted on a small mass produces a greater acceleration than the same force exerted on a large mass. That sounds an awful lot like Newton's second law. But now we're going to look at it from the point of view of two objects, both with the same force on them. Earth is pulled up by the boulder just as much as a force as the boulder is pulled down Earth. We've talked about that before. That's what we were just talking about. A acts on B, B acts on A. So, the forces are equal in strength, but they're opposite in direction. Now this is the weird one. The boulder falls to Earth, and Earth falls to the boulder. The Earth is pulled to the boulder. But of course, we can't really even see this because the distance Earth falls is much less. It's imperceptible, but the Earth is actually being pulled to the boulder. So the pair of forces are the same on them. We said that it has to be, but the key is that the masses are unequal. And if the masses are unequal, then the acceleration is going to be unequal because it's inversely proportional to the mass. And if the force stays the same, the acceleration is going to change due to the differences in the two masses. So because the Earth has a huge mass, we don't sense that very, 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 very tiny amount of acceleration as it's being pulled up to the boulder. This one's a little easier example to see because these are two objects that are closer in mass, in their magnitude of mass to each other. If you ever watch a cannon shoot a cannonball, you're going to see the cannon recoil. It's going to jump back a little bit, and of course the cannonball is going to head off towards its target. But you notice that the cannon does move, but its acceleration is much smaller than the cannonball because the mass of the cannonball is much smaller. So we have an interaction between the cannon and the cannonball. The force that exerts on the cannon exerts on the cannonball is equal and opposite the force the cannonball exerts on the moon. Remember, A acts on B, B acts on A with the same amount. But you might expect the cannon to kick more than it does, and the cannonball moves fast compared with the cannon. But what you have to consider is the masses. If we just consider the force, it would be kind of confused by this, but you have to look at the mass. Here's how you can see. If you look, the force of each is equal to each other, but the small mass of the cannonball leads to a large acceleration, and the bigger mass of the cannon is going to lead to a very small acceleration. So that would explain the changes in the velocity of the two. The cannonball is going to accelerate at a much higher magnitude because of its very small mass, whereas the cannon is not going to accelerate that much because of its large mass. And this is Newton's second law. Now here's a great picture. I love this picture. It's a picture, I think, of the USS Iowa, which was one of the last battleships that contained these gigantic guns. And these guns, you could shoot a Volkswagen Beetle out of these guns. That's how big the guns are. And you can see the massive amount of force that this battleship is producing on the shells. And you can see the boat actually is being pushed to its port side, and you can see the shells are going off to the left in the picture, and the ship is being pushed off to the right in the picture. And that's a massive ship. Now we can also talk about this with a balloon. If you ever take a balloon and you blow it up and you let it go, it'll shoot one way. But what's happening is that the air is escaping out the back of the balloon, and they're going in opposite directions from each other. Now, this is not that much different than a rocket ship. What happens with the rocket is that they have a gas in the back that is exhausted, ejected from the engine of the rocket, and there's a force on the gas of the rocket. From the gas then places a force back on the rocket, and the gas goes one way, the rocket goes the other way. So you can think of each molecule of the exhaust gas like a tiny cannonball shot in one direction, and then the rocket will go in the opposite direction. So now here's a misconception about this: is that if you if you that a rocket actually pushes against the atmosphere, but that's not true. It's really the gas is going in one direction and the rocket going the other. It's just like the recoil of a cannon. And actually, rockets work better in the atmosphere because there's no air for air resistance. Now here's another example right here. I want you to look at the helicopter in the bottom picture. The helicopter, its blades spin, and as a result of that, there's air forced downward. So this is the action. Now the air that the blade forces down pushes back up on the blades, which causes the reaction force, which causes the helicopter to go upwards, and that upward reaction force they actually call lift. And when your lift, or the force pushing the helicopter back up, is equal to the weight, the helicopter is going to hover. But then when you get the lift greater, the helicopter will actually climb upward. Now, birds and airplanes also fly for the same reason. The airplane wing is shaped in such a way, and the bird's wing is shaped in such a way that it forces the air to go downward, and as a result, it gives lift to the wings of the bird, causing the bird to go upward. And the same thing occurs in an airplane. It's deflecting the air coming at it, and this also produces a lift on the airplane, causing it to go high. Now, this is one you got to remember for Blue White Day. Think of this example: you have a bunch of boys and girls on a polished floor that's somewhat slippery, and the boys, if you have the boys just wearing the socks, and the girls all get to wear rubber-soled shoes, who is going to win the tug of war? Now, you would probably be tempted to say the boys because they're bigger and they're stronger, but that's not the case. What's going to happen is the girls are going to win, because the boys are not going to be able to get any traction on the floor. Remember, the forces that they're going to exert on each other are going to be the same on the rope. The difference is that the girls are going to be able to exert a force on the floor, and the boys will not be able to exert that force. And as the girls push on the floor, they're going to pull the boys on towards them, because the boys are not going to get any traction on the floor. So what I always say in terms of Blue White Day, the way this works is that the team with the greater leg strength is going to win the tug of war. So just remember that. The more legs you have, it doesn't matter with the upper body strength as much as it matters how well you can move your legs in a tug of war. So why do objects that experience the same amount of force accelerate at different rates? It's all in the mass. The smaller the mass, the greater acceleration. And it's going to accelerate greater than the object that's acting on it or reacting that has a larger mass. Just think of the cannon and the cannonball. When the cannonball is shot, you're going to get the recoil of the cannon. It's going to be very small compared to the acceleration on the cannonball. So that's the end of the first half of this chapter, and hopefully this was a success. And if you have any questions, definitely feel free to write them down and to let me know. And don't be afraid to go back through this podcast again if you got things wrong, and I'm sure you probably used the pause button at some point. So we will see you in class soon.